Hello, welcome back to Learn Physics. In today's topic, we are going to discuss the gravitation revision topic. So, in last video, I did that gravitation theory portion at a glance, and within 20 minutes, how we can cover up the gravitation portion. I told you, I think it is thorough for you, that chapter. If you have any doubt, in the description box, I already gave that detailed playlist, the full playlist of the explanation of this chapter. It's given in the description box. If you have any doubt, please go through that. Okay, so today we will do some of the numericals based on this chapter. Okay, gravitational force on the surface of the moon is only 1/6 as strong as the gravitational force on the earth. What is the weight of a 10 kilogram object on the moon and on the earth? So we should gravitational force on the, so first question is gravitational force on the surface of moon is, gravitational force on the surface of moon is 1/6 of as strong as the gravitational force on earth. Okay, this one in theory also we learned. Listen how we learned. See, gravity, acceleration due to gravity of moon is equal to 1/6 of acceleration due to gravity of earth. Like that we learned, right? So what is the weight of a 10 kilogram object on the moon and on the earth? So mass of the object is 10 kilogram. Then what will be its weight on earth? 10 into weight as formula as mass into acceleration, mg, acceleration due to gravity. So acceleration due to gravity, we know the value is 9.8 meter per second square. So 10 into 9.8, so we will get it as 98 Newton. So what will be the weight on moon? See, weight on earth is 1/6, right? So 1/6 of weight on earth will be weight on earth. So it will be equal to 1/6 into 98. So he will feel it as 16.3 Newton. Okay, that will be the weight on moon. Okay, so the next question is, a ball is thrown vertically upwards with a velocity of 49 meter per second. Calculate maximum height to which it rises and the total time it takes to return to the surface of earth. So it's given as an object is thrown with a velocity. It's throwing with a velocity means initial velocity is given as 49 meter per second. So second question, initial velocity is given as 49 meter per second. Calculate the maximum height to which it rises. So maximum height, how much distance it would have covered when it is moving upwards. So when it is moving like this, what will be the acceleration? Acceleration will be acceleration due to gravity, 9.8 meter per second square. But it is moving against gravity, right? So we should give a negative sign, opposite to the direction of applied force. So it is negative. Then next we should consider what will be the final velocity. Final velocity, see, we are throwing with a velocity. So when the velocity becomes 0, it starts to come down, right? So the final velocity will be equal to 0. Okay, then we need to find out the distance covered. How we can find out? S is equal to ut plus half at square we can use, but this here t is not there, so we can't use this formula. We can use another formula, v square minus u square equals 2as. Therefore s is equal to v square minus u square divided by 2a. v is 0 minus 49 square divided by 2 into 9.8, that is minus 9.8. This negative and negative will get cancelled. So 49 into 49 divided by 9.8 into 2. Okay, so here while we are cancelling this one, we will get it as 9.8. How much it will be? We will get the answer as 122.5 meters. So while solving, we will get the answer as 122.5 meters. This is the maximum height which is attained by this object. Then next is the total time it takes to return to the surface of Earth. So what is the time required for the object to reach to this height? That much distance once more it is coming. See, what will be the time required for this distance? The same will be to coming back, isn't it? So T2 will also be equal to T1. Okay. So first we can find out the value of T1. Which formula we can use? See, this formula or V is equal to U plus AT. Any one formula you can use. So here S is equal to, so or V equals U plus AT, that will be more convenient I guess. So V is equal to 0, U is 49 plus 9.8 into T. Therefore, we will get T as, here A is negative, right? So T we will get it as 49 divided by 9.8. Okay, 490 divided by 98. So here 49, 10, here it is 2, here 5 seconds. So together how much distance the moving upward and downward together it will be 10 seconds. Okay, clear? So next question is, a stone is released from the top of a tower of height 19.6 meter. Calculate its final velocity just before touching the ground. Okay, a stone is released from the top of a tower which is having 19.6 meter. So a stone is released from a height which this height is 19.6 meter. Okay, calculate its final velocity just before touching the ground. So it is, a stone is dropping. While it is dropping, what is the initial velocity? Initial velocity is 0. While it is throwing, final velocity will be 0. While we are dropping, initial velocity is 0. Distance covered is equal to 19.6 meter. Acceleration, since it is moving downwards, acceleration will be 9.8 meter per second square. We should find out the final velocity. What is the formula? We should find out. Relating all these four quantities, which is the formula we know, V square minus U square equals 2AS. Therefore, V equals root of U square plus 2AS. What is U? 0. 2 into 9.8 into 19.6. See, 2 into 9.8 is 19.6. 19.6 into 19.6 under root, if it is getting 19.6 meter per second. So this is the final velocity. Okay. So the next question is, a stone is thrown vertically upward with an initial velocity of 40 meter per second. It is throwing upward with an initial velocity of 40 meter per second. So initial velocity is given as 40 meter per second. Taking G as 10 meter per second square, find the maximum height reached by the stone. So maximum height we should find out. Okay, so what is the displacement and total distance covered by the stone? So a stone is throwing with a velocity. In the question they are telling acceleration, we can take it as 10 meter per second square. But it is throwing upwards, right? So it is minus. It has thrown vertically upwards. Since it is moving upward, acceleration we will consider it as negative. Minus 10 meter per second square. H we should find out. How we can find out? Since it is throwing upwards, final velocity will be equal to 0. Dropping, initial velocity is 0. Throwing, final velocity will be 0. Therefore, S is equal to this formula. V square minus U square equals 2AS. Therefore, S is equal to V square minus U square divided by 2A. V is 0 minus 40 square divided by 2 into minus 10. So it is minus 1600. Negative negative will get cancelled, 20. So we will get it as 80 meter. So that is the distance covered, maximum distance covered. And what is the net displacement? See, when we are throwing, it will go there and will come back, right? So what is the displacement? Final position is the ground, and initial position also ground only. So what will be the displacement? Displacement will be equal to 0. Displacement is 0. Now, what is the total distance covered? Distance covered means total length of the path covered by an object, right? So, upward direction 80 meter, downward direction 80 meter. So, together it will be 80 plus 80, that is 1160 meters. Okay, distance covered means total length of the path travelled. Okay, clear? So next question is, a stone is allowed to fall from the top of a tower 100 meter high, and at the same time another stone is projected vertically upwards from the ground with a velocity of 25 meter per second. Calculate when and where the two stones will meet. Same kind one question in the normal explanation time I did, because it was there in your exercise question. So, top of a tower. So, the stone is, so a stone is falling from the top of a tower which is having height 100 meter. Okay, for the first stone, while we are considering, it is falling from, a stone is allowed to fall from the top of a tower. Initial velocity is 0, acceleration is 9.8 meter per second square, and at the same time another stone, second stone, is projected upwards with the velocity of 25 meter per second. But acceleration we should consider here as negative, since it is moving upward direction. So let it meet at the distance x from the top. Okay, so distance covered is x. Here how much it will be? 100 minus x. Okay, so we can write down one formula here. S is equal to ut plus half a t square. So x is equal to half 9.8 t square. Okay, so here we will get another equation as S is equal to ut plus half a t square. So here we will get it as 100 minus x equals 25t minus 9.8 divided by 2t square. So 100 minus x equals 25t minus 4.9 t square. So here we got this equation like this. Here x equals 4.9 t square. Okay, so if we are adding these two, what we will get? See here, instead of x I can substitute it as 4.9 t square, right? So 100 minus 4.9 t square equals 25t minus 4.9 t square. 4.9 t square, 4.9 t square will get cancelled. So you will get it as t equals 100 divided by 25, that is 4 seconds. So if we are, the time we got it as 4 seconds, and if we are substituting in this equation, x is equal to half into 9.8 into 4 square. So here 8 into 9.8. So here you will get it as 9.8 into 8. 78.4 meters. At a distance of 78.4 meter it will meet. Okay, so So I hope it is useful for you, and if you like the channel, please don't forget to subscribe. And one more thing, see, as usual, whenever the question comes, see, you can pause the video and try to solve, and then just check the answer whether it is getting correct or not. Okay, next day I will be coming with the exemplar questions from your NCERT textbook. Okay, so that's all for today. Thank you for watching. Bye.